Hi all, I'm Pushpa. Welcome to my channel Tech Talks with Pushpa. Today we are going to discuss one of the famous interview question. Can we create our own immutable classes in Java? Yes, we can. What is immutability? Once an object is created, we can't change its value. And in Java, we already know that strings and wrapper classes are immutable ones. More of this is discussed in the previous video. Please watch that for more clarification. As strings and wrapper classes, can we create our own immutable classes in Java? Yes, we can. These are the steps which we use to create our own immutable classes. First of all, the class which we want to convert into immutable, that needs to be declared as a final class, because once a class is final, we can't create a child classes to that one. Declare all the variables in this class as a private so that the direct access to these variables is not allowed. Along with private, these variables need to be final as well. So once the value got assigned to these variables, they can't be changed. And one more point is we need to have a parameterized constructor which should have all the fields of this class. When we are performing a copy inside this parameterized constructor, it should be a deep copy so that data members can't be modified with the object reference. We will see this deep copy more clearly when we write the code. There should be a no setter methods. Because of that, we can avoid a chance of changing the instance variables. Getter method need to return the copy of an object rather than returning the actual object reference. Let's understand these steps more clearly by implementing it in our code one by one. Here we created a simple student pojo class which is having a three variables name, register number and marks, where this marks says that how many marks the student scored in each subject, and a parameterized constructor and getters and setters for these three variables. Let's create the object of the student and see its behavior. In main class, I'm creating an object for this student. Here, I created data for this one where I created a name, register number variable and a marks map. In marks map, I kept two values. In maths, the student scored 90 and in physics, the student scored 75. Now I created an object for this student class with this data. Now I'm printing the name and register number of this class, and I changed the marks variable of this main class. I added one more subject of social with a marks of 80. But this social subject is not there when we created an object for this student one. Let's see how it executes. Here in the line number 20, when I'm printing out the marks of this main class, here we'll have three values of maths, physics and social. What about the student object which we created here? Because at the time of creating this object, we are having only two values in the marks, but we changed marks after the object creation. Let's see what the student.get marks will print out. Let's run this code. See, the student class can name is Pushpa, register number is 529, and the marks map of this main class is having a three variables of social, maths and physics. As we know, map doesn't saves keys in an order wise. It's a random one. So that's why we got social first, maths and physics next. See here, even the student class ka marks is also having a three values, even though the object got created before adding this social into this marks one, because the student class is a mutable one. Here, the marks of the student class is referring to the same address of the marks map which is there in the heap memory. Now let's create the same student immutable class and let's see how it works. Here I created a student immutable class. The first thing for an immutable class is to be, we need to declare that class as a final one because we should not allow any child classes to get created for this class. Here I created a three variables, name, register number and marks with the private and final, because we don't want these variables to get accessed directly, nor when values of this object got assigned, we don't want to change that one. Here I created a parameterized constructor which is having all the fields of this class. See, when we are dealing with an object, map is an object. When we are dealing with a fields which are objects, we should not assign that objects directly with the reference. We have to copy that values. For suppose in student class, we made this dot marks equal to the marks which we passed. Here, the student class ka marks is just holding the address of the marks object which we passed here. In immutability, it should not happen like that. Here we need to create a deep copy. What is deep copy is like here we take this map marks and we create a temporary marks map which is having the same value of marks. Now the address of this marks map is different and the address of the temp is different. What happened in our memory? We created a same object with a different memory address. Now this immutable class marks variable will hold the address of this temp value. Means the address of this marks is different from the address of this marks. So if you make any changes in this marks object, it won't reflect over here because the address of both the object is different. Here we created only the getters of these fields, no setters. Because if we create a setters where we can change the value of these fields using a setter methods of this object. So we don't create any setter methods. We create only getter methods to access the values of these fields. When we are having a getter method which is returning an object, we should never return a direct object instance. We have to return a deep copy of that. Here we created a temporary map. We are writing a for loop which copies all the key value pairs from the marks and places it into a temp map. Now we return this temp variable to avoid returning the direct object instance of this class map. Now let's create the object for the student immutable class and see how differently it behaves from the student class we created. Here I'm creating the object of student immutable class with same values where we created with the student class. Let's print the age and register number of the student immutable class which we gave. Let us add one more subjects to the marks map of this main class. Let the new subject be chemistry and the student received an 85 marks in this chemistry. And here this marks of the chemistry got added after creating the object of student immutable. At this point, when we created a student immutable object, the marks is holding only 3 subjects. After creating this student immutable, we added one more subject to the marks map of this main class, which is a chemistry one. Now let's print this marks map of a main class one and the marks map of student immutable as well. Now let's see how this code executes. See, when it comes to a student class, the name, register number, and the marks map of this main class is having a 3 subjects, social, maths, and physics. The same marks map of a student class is also having a 3 subjects, even though this student class got created before adding this social subject. But see how an immutable student class got created. Here at the point of creating a student immutable class, this marks is holding 3 subjects. Uh, the name and register number is same, but the marks map of a main class, which we printed here in the line number 31, gives 4 subjects. But the marks map of a student immutable is having only 3 subjects because at the point of creating this object, the marks map is having only 3 subjects. Any changes which we made to the marks map of this main class is not reflecting in the student immutability. Because in immutable object, once it got created, it should not change its value. We achieved this by doing a deep copy. I hope this concept is clear. If you like the content, please like, share and subscribe to this YouTube channel. See you in the next video.